Okay, so derivatives of exponential functions. This is just one of those that you need to memorize that I took off your plate the first couple weeks of school because there were so many other things to memorize. And really, you pretty much know how to do this if I show you one connection. So at the top here, this is how to do it. If you have a function that's a number to the x power, this is what its derivative is. So you can just straight up memorize that and you will be fine. But I think it makes more sense to lean against one that we already know. So the derivative of e to the x, we've been saying is what? E to the x. But if I follow their formula, it says it's e to the x times the natural log of what?
E.
And what is the natural log of e? 1. Which is why we don't need to say that all the time. But when the base is not e, the natural log of the base is not 1, and then it's important to keep up with that. So if it's 3 to the x, it's going to be 3 to the x times a natural log of 3. If it's 7 to the x, it'll be a 7 to the x times a natural log of 7. So if you understand that it's really true for question 1, we just don't need to say that, it's unnecessary because it ends up being 1, then you already know how to do these questions. Of course, the only thing that can make the questions a little longer, or even the tiniest bit harder, would be chain rule. So if you have a number to some power, you would get the number to some power. So 8 to the x squared is going to give you an 8 to the x squared times the natural log of the base. So times the natural log of 8. And then this is reminding you to consider, we'll do this in red, chain rule. So if the inside doesn't have a derivative of 1, we need to come back and multiply by the derivative of what's being plugged in. So exponential function 5 to the 2x is going to be a 5 to the 2x times the natural log of the base, and consider chain rule. In this case, times 2 more. 10 to this mess is going to be 10 to that mess times what else? Okay, natural log of 10, and then times, what's the rest of the mess?
3x squared plus 5.
Okay, so all of that makes up the derivative. Just because the derivative is long and messy doesn't mean that it was necessarily that much harder. Now, I will say that I know our next test has 1 or 2 of these on there. I don't remember, honestly. And with the exception of last year, this was probably one of the more missed questions. Not because it's hard, especially when you compare it to related rates. It's not that it's hard, but I think sometimes when things are not difficult, you guys don't worry about them, and that means you don't look it over before the test, and then that means you sometimes miss it. I kind of highlighted that to last year's group, and they did much better. So I don't think you'll struggle with this, but again, 1 or 2 questions on your next test will be this topic. So make sure you give 30 seconds of review at least. There's also a couple on the test review to remind you. But okay, so now we need to kind of break into 2 paths here. So as I said, I want to answer some of your homework questions. So as I mentioned last class, related rates can vary quite a bit in difficulty. So you should have struggled with a couple of those questions on the circuit, which is fine. Since I didn't give you enough class time to finish that and get your questions answered, and I didn't have work or help for you on the website, I didn't expect you to connect all of those dots. But some of you don't have questions, or some of you have very few questions. So let me speak on today's handout so that you know how it's kind of formatted. So on the front, it's got 6 basic related rate questions. Make sure that you note that the answers to the first 6 are on the bottom. So make sure that you're getting the answers right as you move along. After the first page, all the other questions are multiple choice questions from past AP exams. So I like you to see these so that you can see the varying difficulty of related rate questions that they ask, easy to difficult. Now, of course, these are multiple choice, and on the very bottom of the very back page, it has the answers. So, of course, when you turn this in, you need to make sure that you turn in your work also. If question 11, you only circle E as your answer, I know the answer to 11 is E. You need to have some work that shows that. I don't feel like I should have to say that, but that comes up every year. And the last thing I'll say about this one is question 6 is definitely the hardest. The multiple choice question 6. So I'm not telling you not to do it, but if I was you, I would probably do it last. I wouldn't worry about it until I had the other stuff done. So, as you get all of your questions answered from the circuit from last class, or as someone's asking a question from the circuit from last class that you don't need help with, do a question or two from today's handout 36. And then, of course, at the end of class, I will tell you how much of that you need to have done by next class. So, okay. So from last class, again, my voice is trying to give out on me here, so I apologize. But from last class, I know we worked on some of this stuff together. Which other questions can I help with, though? Yeah.
Number 12.
The last one. Is this your 12?
Yes, sir.
Okay, so a couple things about question 12 is there's a lot of parts to it. So when I redid this one a couple days ago, I actually made a couple small mistakes and had to erase and start over. And 2, I think there's some calculator information that you guys may not be up to speed on that may have made question 12 hard to finish. But what I really like about this question is it talks about profit, revenue, and cost. So I don't know if you're aware of this, but if you plan on being a business major, nowadays you have to have Calculus 1 to get a business degree. And it's really for a big part of this, because revenue is the money you're taking in, cost is the money you're spending, and the profit is the difference between those. But if you're running a business for yourself or for somebody else, you want to minimize costs, you want to maximize profit, and that's a big, well, you may not see it right now, but that's very directly related to derivatives, and we'll talk about that in depth this semester. So, but this one just straight up says profit is revenue minus cost, and revenue is 50x minus cost. Right, like this. Make sure when you subtract costs, you distribute that negative to all 3 terms. Okay, and then so there's no secret to what our geometry formula is. I guess this one's not really a geometry formula, even though most of them are. But now, the most important step in all of these questions, because this is the calculus step, is taking the derivative of p would be 1, except you're taking the derivative of p with respect to time, t. So you need a p prime. The derivative of 50x is usually just 50, but we're taking the derivative of x with respect to some other variable. So it's 50x prime. Power rule, but I'm taking the derivative of x. Power rule, but I'm taking the derivative of x. Power rule, but I'm taking the derivative of x. Every single time you take the derivative of something with respect to time, unless it's the time variable, you got to create that variable prime. Now, to finish this question, if you plug in all their information, like they tell you this is 4.544. They tell you x prime is 0.05. X prime is 0.05. X prime is 0.05. X prime is 0.05. You plug that in everywhere it's supposed to go, and you plug in the derivative of p, then you're left with an equation that only has x's. So it is solvable now, but to solve this you need to use your calculator. So one thing we'll do in the next couple weeks is I have a circuit that is not calculus based, but it makes sure that you know all of the calculator stuff you need to be able to do. So most of the time what I would do is graph this as a line in my calculator, and then graph all of this as a line in my calculator, and I would just look for the point of intersection, and the x value where they intersect would be the solution. But I want to also show you that your calculator has something called equation solver or numeric solver, and it would be good for you to know that it exists so that you can practice with it sometimes if you want to, so that you could maybe use it as needed. Oops. Okay, so if you want to pull up math and go to the bottom, it either says equation or numeric solver. You hit enter. You put one side of your equation in for E1, you type in the other side of the equation for E2. I just did this second period, that's why it's already in there. Now again, you have to practice this sometime to be able to do it because it's not super intuitive. But you have to go down, down, and then your answer will be right here, but whatever answer is right there right now is from the last time I used this. I just changed it so you can see it. But this is like not the solution to this, but the solution to the last time. If you hit alpha enter, notice how it has the word solve in green there. So hit the green button and then hit enter. It will update x equals with the solution. So it'll figure out what value of x makes that true. 1.185. When x equals 1.185, which loops back to the front, and that was supposed to be the last question, so that makes sense. So 5 seconds of me saying that again. Your calculator can solve equations for you if you go to math, all the way at the bottom, equation or numeric solver, one side of your equation in here, other side of your equation in there, go down. This can say anything. This is not your answer. It's not going to show your answer until after you hit alpha enter. Okay, well, this one has more than one answer, but x would be like how many things we sold, so that doesn't make sense. So I didn't really want to go this in depth on it, but so this is obviously a quadratic, so there is two solutions to this. The limitation of the equation solver is it can only show you one answer at a time. So this is where you sometimes want to guess. If I think there's an answer near -5, I can put a -5 and then tell me to solve, and it will find the answer closest to -5. This doesn't make sense in the context of this question though. If I think our answer is close to 50, put in 50 and then do alpha enter, and it will find the answer closer to that. So it's not smart enough to list out every possible one. That's just how it works. So it's not perfect, but just so you know, that is a pretty good tool to use, but you probably won't use it correctly in the middle of a test if you don't practice it occasionally. Okay, so that's probably more than you wanted, but do you get what you needed out of that? Okay, I assume somebody else was going to ask about 12 also. Is there anything else about 12 I can help with? Okay, what else can I help with from the circuit?
11.
11? Is this your 11?
Yes.
Alright, this is also a great question to ask because y'all didn't get to this last time, and there's something that happens with cone questions that's not intuitive, and you probably didn't think of it quite on your own. So let's go ahead and start it and just assume it's like every other question until we discover where we kind of hit a roadblock. So conical paper drinking cup. Conical, fancy word for cone. This guy has a height of 6 inches and a radius of 2 inches at the top. How fast is the water level in the cup rising? So how fast how is the height changing, h prime, if we pour in water at 1 cubic inch per second? So that's definitely a rate, but it's a rate for what? Very good. So if you can't catch that out of the context of the question, the unit should help you. Area is always squared units, volume is always cubed units. When the water has a height of 2 inches. So what I suspect that you did is you started off with a geometry formula, volume of a cone, and that's good, that's fine. You should have taken the derivative of this with respect to time. 1/3 pi is just a number, so I'll worry about that later. But notice, to take the derivative of r squared h, you have to do product rule. You have to do the derivative of r squared with h left alone, and then the derivative of h with r squared left alone. That's correct. It's just not useful in this question. The problem with this question is, I know what h is. I want to know what h prime is. I know what v is, or v prime. I didn't write it down. But there's too many other things that I'm missing. I don't know what r is. I don't know what r prime is. And there's not enough information for me to figure this out. Except, and here's the catch, and this is why this is a good question to ask. I'd be concerned if y'all didn't ask this. This information, you have to understand that cones, if you break this down like this is like a right triangle, and these sides are always proportional. So if this is 2 and this is 6, that means when this is 1, this is 3. In other words, the height is 3 times whatever the radius is. And it will always be that proportion no matter what the height is. It always follows this proportion. So I could solve this for r. For this particular question, r is h over 3. And instead of doing the derivative of this guy, which created a bunch of variables I don't know, I will rewrite our volume formula, but instead of r squared, I'm going to put h over 3 squared. So this is like h cubed over 9, or 1/27th pi h cubed. So are you okay with that substitution? Okay. And now this is going to work out great, because now when I take the derivative, I can do the power rule. Make sure that when you're taking the derivative of v with respect to time, you get a v prime. If you're taking the derivative of h with respect to time, you get an h prime. Now it's written in a way where I have all of this stuff that I need. This is 1. 1/9 is just a number. Pi is just a number. H squared, I've got h. And h prime is the only thing that I don't know. So then that allows you to solve that. But this, you only have to worry about this type of thing with cone questions, that proportion. Sometimes you need to change the r stuff in the h's, and sometimes you want to change the h stuff in the r's. I'm not saying you should do that right away. Wait and see that you need to do that like I did. Okay, so then in the end, I mean, we can finish it, but now it's just a matter of 1 divided by 4 times 9 divided by pi gives h prime is 0.716. So to me, for that reason, 11 was the hardest question. And I don't think many of you guys should have been able to figure that out, because unless you thought to do that replacement, which I didn't give you any indication or hint of that last class, that's why that would have been a hard one for you to figure out. We just ran out of time before you got there last time. Okay, anybody want to ask anything else about 11? Okay, somebody else for another question from 34, assignment 34. Okay, anybody who has asked a question had a second one from it?
Could you scroll down to 8? I know you already did it, but
Is this 8?
yeah.
Oh, I guess we did talk about that a little bit in this question, but not extensively, so. Did you have something about 8 you want to ask, or?
Did you work through it?
Sure. Okay, so we've got a conical pile, so that's a cone. Radius is twice the height. So this is talking about the thing I said on question 11 that I didn't think you were going to figure out without a hint. Find the rate that the pile is growing in cubic feet per hour when the radius is growing at 0.5 feet per hour and when the radius is 2.5 feet. All right, so we know what shape it is. Conical pile. Conical is this fancy word for cone. So start off with the volume of the cone formula. So either memorize that one or think about how I told you to find the volume of three-dimensional shapes last class. This has one base, so the volume will be 1/3 of the area of the base times the height. The base is a circle, so pi r squared. Now, just like question 11 that somebody just asked about, you can just dive into the calculus right now if you're careful about product rule. The problem is some of this stuff you don't know and you can never find. R is fine, R prime is fine. I don't know H. I don't have any way to find H prime. So that's a problem. But if this is true, if R is 2 times H, that means H is R over 2. So maybe instead of saying H, we try R over 2. And this is only for this cone because they told me, but this could be his formula when I switch H's in terms of R's. Now I can worry about the derivative. And since I replaced all the H stuff with R stuff, now I only need to know R, V prime, or R and R prime, which I know, to find V prime. So our answer is going to come from 1/2 times pi times 2.5 squared times 0.5. Whatever that mess is. That's 4.909. Now, one other thing to keep in mind is sometimes you want to change the H stuff into R's, and sometimes you want to turn the R stuff into H's. Just depends on the question. So, make the replacement. If you make a replacement and it's giving you the opposite information that you have, just go back and make the other replacement. Okay, it seemed like you guys are running out of questions on that, but I want to just double check. Nothing else from the circuit I can help with. Okay, then go ahead and start if you haven't yet, on 36, the handout you picked up on the way in, you can see, well, I don't know if you can read it very well. The contrast is kind of bad, but for homework, what? Or later? No, you don't have to turn in the circuit today. No. I will take it up for points, but it's not today.
You will take it today?
I will take it up, but not today. I will give you points for doing it. I just give you more time. Okay, so down there under homework, I guess if you didn't have assignment 34 done, but you guys finished asking all your questions, so that shouldn't apply to you. But by Thursday, I'm asking that you have at least 10 questions from this assignment 36 completed. 10 questions that you finish, get the right answer to, and feel good with. So if you try question 1 and you get stumped on it, that doesn't count as one of your 10. If you try question 2 and you don't know how to start it, obviously that doesn't count as one of your 10. Number 3, you do it, you get an answer, and it matches up with the answer at the bottom. There's one of your 10. So I think you can probably get more than that done, and I will ask you to do the rest next class anyway. But out of these 17 questions on here, you need to feel confident about 10 of them. And of course, within that, you're going to find some questions that you struggle with, but that's okay because you will know what those questions are and you'll have them ready to ask next class. So let me give you a few minutes to get going there. And of course, I will offer as much help as I can. But you can work these in any order that you want. I would probably start with the front page just because AP questions can vary quite a bit in difficulty. They can be pretty straightforward to a headache. Like question 6 is a pretty bad one. But okay, any questions about the agenda today? I'm going to give you 10 or 15 minutes to work, so if you do get hard stuck, just move on. Don't just sit there and wait and waste your time. About 10, 15 minutes from now, I will interrupt and offer some help on the board. Yeah, if you need to borrow a calculator, come help yourself. Just put them back at the end of class, please.
you doing about this?
That's the same thing as.
Alright, it's been a little over 10 minutes here, so I will offer to help out a bit. You want to tell me which one you tried and did not work out for you? If any of them yet. No questions yet? Sure. I'm gonna zoom it way out though. Alright, 3. So we got another cone question. Sounds like. Gravel's falling into a conical pile. So that's a cone. At a rate of 100 cubic feet per minute. So that's going to be how velocity is changing. That's how volume is changing, not velocity. Volume is the one that has cubic meters. So in this problem it's cubic feet. And then the per minute gives us the rate. Find the rate of change of the height. So we want to know h prime when the height is 10 feet. Assume the coarseness of the gravel such that r equals h. Okay, so without putting much thought into this or any of this, I know it's something about volume and it's a cone. So this is probably one of the harder formulas they expect you to know that I won't provide for you. And as we talked about on the circuit, you can take the derivative right now if you do product rule. Derivative of r squared with h left alone, and then the derivative of h with r squared left alone. And the similar issue, and again this issue only comes up with cones, but it comes up pretty often, is you might know the height, you might know v prime, you might know h prime, but you don't know r, you don't have any way to find r prime, you don't know r, so somehow you got to get rid of these r's. Sometimes that means you just need to dig deeper and figure out what r is equal to. In this question you're never going to be able to do that. So we've got to use this guy. R equals h. So I either want to replace this r squared with h squared, or I want to replace this h with r. Now if you're not sure, just go ahead and make one of those choices. Take the derivative, and this would be wrong. If I do it this way, I'm never going to figure out what h prime is because I don't have an h prime. So if you pick wrong, it just takes you 5 more seconds. In this case, instead of plugging in r for h, I should be plugging in h for r. So because of this, I can rewrite this as 1/3 pi h cubed before I do the derivative. Now do the power rule, bring the power down, lower the power by 1, make sure you include an h prime, and then we should be ready to go. I know this value, pi is just a number, I know this number, and I'd like to know that number. So, looks like our answer should come from 100 divided by 100 pi, so that would be 1 over pi. Just what they got. Okay, is that enough? Okay. Anybody else have anything else about this one? Okay, what else you got? Don?
3 on the multiple choice.
Yeah, 3 on the multiple choice is I don't know. I wish I could give you more reassurance, but again, this is just what's difficult about calculus. Calculus concepts are not too hard. Calculus steps are usually not too hard, but any and everything you've ever learned in a math class before can be fair game. The fact that these are real AP questions, you'll recognize this question type from geometry class once I start going over it and start making a picture. But you may not have thought about it since geometry. So we've got a person who is 2 meters tall, walk away from a street light that is 8 meters above ground. So here's my lamp, light pole, it's 8 meters. We've got somebody walking away from it, or walking this way. They are only 2 meters tall. If the person is walking at a constant rate, and the person's shadow, so when the light hits his head, this creates a shadow. This is a shadow. It's increasing at 4/9 meters per second. How many meters per second is the person walking? So I want to know this. How quickly is he walking? So if we know his height and the lamp pole's height, and we can measure how quickly his shadow is moving, we can also figure out how quickly he is moving. So do you recognize this where you have like a small triangle within a big triangle? Does that look familiar? Okay, so how you would have done this in geometry class, and actually a few of my posters up around the room back when I used to teach geometry have this on there. But basically you have to set up a proportion. You need to be careful though, because these two are lengths, whereas these two are rates. You can't mix and match those. So I'm just going to call, I don't know, I'll call this length X, I don't know what it is, and I'll call this length Y, I don't know what it is. So I can set up a proportion and say 2 to 8 is the same thing as X is to what? Very good. Y plus X. So small triangle, big triangle equals small triangle, big triangle. Big triangle is not Y, it's X plus Y. So this is the geometry formula for this particular question. We could cross multiply, we could try to simplify it a little bit, combine like terms, just do as much as we can. But at some point we got to take derivatives. That's the point of first semester calculus, taking the derivatives. So the derivative of y with respect to t would be y prime, and the derivative of 3x would be 3x prime. And one of these I want to know, and one of them I already know. Which one do I already know? So this would be equal to y prime, which is the rate he's walking, and so 4/3. Option D. So of course I want you guys to see questions like this so that we can try to refresh your memory. But just to be honest, this type of similar triangles where you have a small triangle within a big triangle and you have to set up a proportion, you maybe only need to do this once or twice more this year. It's not going to come up all the time. But it showed up on the AP exam, so they expected people to remember that. That's why we want to be know the basics and be as proficient at the calculus as we can, so that sometimes when you get to stuff that you just don't remember, it's not that detrimental because you're solid on enough of the rest of it. So. Okay, maybe one more question from the front page, just because I'm assuming most people are sticking to that.
Did you do number 4?
Can I do 4? Yes. All right, we got a ladder 26 feet long, leans against a vertical wall. Actually, I'll just go out over here. You got the question in front of you. Ladder 26 feet tall. Leans against the wall. The foot of the ladder is being dragged away at 4 feet per second. How fast is the top of the ladder coming down? So that would also be feet per second. If I go ahead and label that now, I don't have to think about it again later. When the foot of the ladder is 10 feet from the wall. So when this distance is 10 feet. All right, so this is the type that I said is the most common. You've got a right triangle, you're interested in side lengths, so probably Pythagorean theorem. Take the derivative with respect to with respect to t. So that creates an a prime, a b prime, and a c prime, because none of those are the same as t. Most people just choose to divide everything by 2 to make it a little bit simpler. Now we need to start plugging in the stuff we have to see how close we are to being done. So hypotenuse has to be c. You have no option about that. Your legs, one needs to be A, one needs to be B, but it doesn't matter which one you call A and which one you call B. So the hypotenuse is 26. How does the hypotenuse change in length?
It doesn't.
Good. Ladder's not changing in length, at least hopefully. A is 10 and A prime is 4. And I don't know B and I don't know B prime. Well, B prime is what I'm trying to find, the rate that B is changing. So I know that's the last key to this. So there must be some way for me to find B. Now notice when I started this question, when I was making my picture, I had no idea that I was going to need to figure out what B was. That's okay. Just do what you know you're supposed to do, and then you'll get stuck eventually, and that is your indicator on what you need to consider. So usually my pictures have too much going on here, so if I just re-sketch it, right triangle, this is 10, this is 26. I can do Pythagorean theorem. That would be the square root of 26 squared minus 10 squared, which comes out to be 24. And then subtract the 40 over, divide both sides by 24, and I get an answer of -5/3. And I already wrote the units down earlier, so I don't even have to think about that again. That would be feet per second. And you don't have to do this, but it's probably a good idea to think about if that makes sense. Because this guy is going down, it makes sense that the answer was negative. If the answer was not negative, you shouldn't just make your answer negative. You need to go back and think about which one of these things, which one of these values you may not have done correctly. sec here. Okay, I'm going to restart the timer here so you can try a few more questions before I am in your ear on the board. You guys do the whole front page already? Nice.
You already do the whole front page?
That's the distance.
Okay. That looks like you're close. Oh, okay, so, yeah, if you divide this over, if you divide both sides by 5/3 of 10, 40 over 5 reduces to 8. And then so 8 over the square root of 10. Did you do pre-calculus last year? Okay, so you remember how we rationalized the denominator all the time? If you rationalize that denominator, it will simplify the numerator.
So you were doing it right, it's just they did more to it. I just took questions on this. Huh? I took questions on this the first part of class today. Why didn't you ask me then?
I just got to this problem.
But this was your homework, so you should have gotten to it already. This is what I'm talking about. You need to put this up and join us so you're not falling further behind. You can catch that up another time. I've already done that, Sonny. I don't know what to tell you. I'm not, it's not, I can only do one thing at a time. I have to stay, yes. So if you're not following that, then you're choosing to be on your own.
Is that the string that he's holding on to, or like the distance like around it?
On ground level. So 150 feet. The string is 100, or 300 feet, I think, so the string is that high wire.
So 150 is the ground. One fifty is the bottom. 150 is like an A or B.
Because that's not true. The derivative of the area is 2 pi r prime, whereas the derivative of that is 2 pi r. Okay, wait, hold on. I might be messing up the question, but they're not the same. Okay, this question there. I'm sorry. Forget everything I said. That was good, okay? So set these two things equal to each other. You're close. Set these two equal to each other. I'm gonna do math yourself. Okay, and then what'd you do? Alright. 1, and there you go. Also on the front page, I know you need volume of a sphere for question 2, and you're welcome to look that up or in your notes, but remember that's the one you don't have to memorize. The only reason it's not in the question on number 2 is because the front page is not AP questions. If any of the AP questions were about volume of a sphere, they would put it in the question because they don't expect you to memorize that for whatever reason. They just kind of pick and choose what they think is important. Let's start this.
Testing scores or something. Okay, so like there was sheets of paper and it said like must read like this is important for your page or whatever. And it said it 3 times on the sheet. You know, that's why I was like, well, they really want them to read this because it's like a yellow sheet and it said like 3 times the same exact thing. And this one that comes out and you staple it to the atlas paper. That's what we're doing. Someone comes in and says, you know, you're supposed to cut those apart. Like it's supposed to be one
Oh, yes, yeah,
per
I
page.
got 6 things.
So we had to, and we had like a cutter, so we had to like unfold them and like cut the other 2 off.
Oh my god.
It was not, and she was
They
like,
were not playing at all. You're
no,
supposed to do
and
it.
she was not happy about it.
There's some press in that room.
Yes, they happened to put a paper cutter behind Gabby. Like, how are we supposed to know that's what it was for?
No, I would never say anything. They're just like making sure that they read it.
No, I remember I really said, like, wow, they really want them to read this. And then just kept stapling. It's like bold and like yellow paper and it was just thick.
I haven't done it yet. I'm about to finish 6. 6 is the hard one? Yeah. I skipped it. I got it. It took a long time for me to figure out. So I started with this equation, and since this is 3/4 this passage,
Yeah.
and then so you can factor out the b prime as a 3/4 a plus b equals 0, and then you can, since we know c a equals square root b squared plus 1600, and then you can plug that in for a, and you can do a bunch of stuff. And so b equals 24 and a equals 32.
I used to feel so fall. It kind of feels like winter. I could be in some 80 right now. Oh, I figured out our song Is that what it is? Okay. They said it was speech therapy, I heard that from my buddy, so I get that. Okay.
That's what my buddy said to her. Well, my buddy's friend.
Bro. Yeah, my dad's definitely from
Yeah. I'm saying.
He has 2 moms
All right, it's been over 10 minutes, so I will offer some more help. Is there others from the front page? Just from the front page right now, Chris? Sure. All right, so question 6 from the front page has 2 different parts. It says 2 sides of a square are increasing at 3 centimeters per second. So, since it's a square, they've got to be increasing at the same rate, or it won't be a square after the first instance. When each side is 5 centimeters, what is the rate the area is increasing? So, sounds like they want A prime. So, square area must be, you're thinking cube. Square area of a square is just side times side. So A prime would be 2s prime, derivative with respect to time. So your first answer should come from 2 times 5 times 3, or 30. Okay, and that would be, area is always squared units, so centimeters squared, and it's A prime, so there needs to be a time component, centimeters squared per second. There's the first answer. Okay, part B. At what rate are the diagonals increasing? So this is a diagonal and this is a diagonal. They're the same size, same length, so they're going to be increasing at the same rate. So if I want to figure out something about this length, you need to realize you've got right triangle. This is going to start off as Pythagorean theorem. After you take the derivative and divide everything by 2, it's going to look like that. I've got A and B are both 5. A prime and B prime are both 3. If you're trying to solve for C prime, how is this increasing? You realize now that you've got to know what C is before you can solve this. But if this is 5 and this is 5, then what is that going to be? Very good, 5 square roots of 2. So you could do Pythagorean theorem there. It's also a special right triangle. That's how you can get that instantly if you know your special right triangles. So this just ends up being 30. And so you could divide both sides by 5 square roots of 2. And 30 over 5 reduces to 6. And then that's where they came up with that as an answer. So it's kind of confusing because in number 5, if you didn't just compare decimals, to get the correct answer to number 5, you have to rationalize your answer. But truthfully, in calculus, we tend to not rationalize ever. We just don't care if square roots are in the denominator. Rationalizing is more of a trig thing because, like, sometimes in trig, you need to be able to say, like, you know, where cosine is this, and if it doesn't look familiar, you've got to have practice changing it to look familiar. So rationalizing is super big in trig. Calculus, we basically just don't do it. So that's why they left the square root in the denominator. Okay, anybody else have something specific about question 6, A or B? Okay, then was there others from the front page before I go past that? Yeah. All right, small balloon is released at a point 150 feet away from an observer who is on ground level. So observer, 150 feet away. My balloon is released. If the balloon goes straight up at 8 feet per second, how fast is the distance from the observer to the balloon? So how many feet per second? I know it's feet per second because this is feet per second. They're both rates. When the balloon is 50 feet up. So, like I told you last class, and you're probably starting to believe me now, Pythagorean theorem's the most common related rate. A squared plus b squared equals c squared. Take the derivative with respect to time. So you need a prime, a b prime, and a c prime. Divide everything by 2 at some point, now or later, and then start plugging your stuff in. So hypotenuse has to be c. C prime is what I'm trying to figure out in this question. I don't know the length of c, so that's going to be on my to-do list later before I get this answer. Then which leg you call A and which leg you call B don't matter. So A looks to be 150 feet. How is the rate of change of A? How is this length changing? It's what? It's not changing. The balloon's going up, but this distance, assuming the balloon's going straight up, this 150 is staying 150. So it's not changing, 0. There's lots of zeros in these questions. Okay, and then B times B prime. So you get 400 is equal to C times C prime. So the last real hurdle is trying to figure out what C is. But I know this is 150. I know this is 50, so I can do Pythagorean theorem for the third side. It's 25,000. That's not 25,000. It's the square root of 25,000. So it looks like our answer is going to come from 400 divided by the square root of 25,000. Now here it just depends. Obviously we're aiming to try to get the answer at the bottom of the page. But if you had a calculator, you could type all this in your calculator, get a decimal answer, and if it was a free response on the test, you can stop there. You never, ever, ever, ever have to do arithmetic. This is considered arithmetic for FRQs. So you could stop there, and it's my job to figure out if yours is equivalent to what I've got. But if this is multiple choice on a calculator, you could type this in your calculator, get a decimal answer, type in answer A, look at its decimal, type in answer B, look at its decimal, type in answer C, look at its decimal, and see which one's equivalent. And the one that's equivalent would be the one that was 4 square roots of 10 over 5, like they have listed there. But if it was no calculator, the only way you could move forward, and this is quite a bit, it's a lot to ask, but you could simplify the square root of 25,000. It's like, I don't know, 25 times 1,000. I'm sorry. Yeah, I'm getting there.
Like a,
10 times 100, which is 2 times 5, which is 10 times 10, which is 2 times 5, which is 2 times 5. So the square root of 25,000, even without a calculator, could be broken down into 1, 2, 3, 4, 5 fives, and 1, 2, 3 twos. So since it's square root, you got to pair things up in twos. You could bring out a 5, bring out a 5, and bring out a 2. So that would be 50. And you're leaving behind a 5 and a 2, so that leaves behind a 10. So if you had to do it by hand, you could reduce the square root of 25,000 into 50 square roots of 10. And then of course 400 over 50 reduces. And then what else could we do? Because this still doesn't look right. Right, so we could rationalize. This is where I was saying a minute ago, we almost never rationalize in calculus. The only reason I'm doing it here is because I'm trying to make it look like theirs. So we can multiply the top and bottom by the square root of 10. And then after you do that and reduce, it will look like theirs. So how much of this you have to do just depends on if you have a calculator or not, if it's a free response or a multiple choice or not. So I did it all by hand though. So it is possible. I will also add though, that just for your guys' knowledge, and I'll say this a bunch more before we get there, but on your AP exam, the multiple choice questions, they either give you an average of 2 minutes or 3 minutes per question. Non-calculator questions, you get 2 minutes on average. Calculator questions, you get 3 minutes on average. So could this be a non-calculator question on the AP exam? It could, but they're going to realize that you're not going to do this in 2 minutes. So they would balance it out with some shorter questions so that on average you should be able to do them in 2 minutes. This question should probably take you about 6 to 8 minutes to do by hand. So, all right, so again, probably more than you wanted to know, but okay, let me offer, if we've got time. We do. We've got about 15 minutes here. Is there one more I can maybe help with? I really like some of these multiple choice questions, but yeah, well, number one, the multiple choice number one, sure. All right, we've got volume of a cone has radius r, height h is given by the volume formula. Now again, they don't normally give you volume of a cone formula, but it looks like they did this year. If the radius and height both increase at a rate of 1/2 centimeter per second, so radius is 1/2 and height is changing at 1/2 centimeters per second. At what rate in cubic centimeters per second is the volume increasing? Cubic centimeters per second. When the height is 9 and the radius is 6. All right, so they're telling us the geometry formula we should use, so that was nice of them. Okay, but to take the derivative of this, the derivative of v would be, okay, constant multiple rule. This is just a number, so we can just take that number times this stuff. What rule do we have to use for r squared h? Okay, so take the derivative of r squared times h left alone plus the derivative of h with r squared left alone. You okay with that? Now, the first 3 or 4 questions you guys have asked today about cones, we didn't have all this information. So we had to figure out how R and H were connected, make a substitution back here so that it was all in terms of R or all in terms of H. But for this question, I think they give us it all. We know R is 6. We know R prime is 0.5. We know H is 9. We know H prime is 0.5. And we know R is 6 again. So, I mean, we have everything we need, just kind of messy looking. So, let's see if I can do this without a calculator. That'll be a good challenge. Let's see, 2 times a half goes to 1. 9 times, or 6 times 9 would be 54. This would be 36. Half of 36 would be 18. 54 plus 18 is 60, 72. 72 divided by 3 is 24, I think. And then times pi, 24 pi. So, by far the hardest part, it sounds like you caught that. This has to be product rule, but unlike the other ones you guys asked today, this one gave us all of that stuff that we needed. So, even though there's a lot of different variables there, just plug them all in and do the arithmetic. All right. Okay, so we're down to about 10 minutes here. So as always, you're welcome to keep working. I need to first make sure you know where you need to be by Thursday. So as I said earlier, I'd like you to feel good about at least 10 of these questions. You've got 6 on the front page. You've got 11 multiple choice. So there's, 10. That gives you 17 questions. So you need to stick with it long enough that you feel good about at least 10 of them. Some of them that you try that you can't figure out don't count as your 10, but it's good to know what those are so you have those ready to ask next class. And I think that's it. I would save question 6 to the very end. 6 is kind of a pain. But yeah.
Do you have recordings of the circuits work on your website?
I'm sorry?
Is there recordings of this circuit work on your website?
Just the questions that were asked. Well, plus what might have been asked in past years. So that's where we need to be by Thursday. Everybody okay with that plan? So a few of you may not even have any homework, but these just take a lot of practice before you get the hang of what the process is supposed to be. But hopefully you like these. These are definitely one of my favorites.
On 8, is this right angle staying true, or is both sides changing?
Say what?
Is this right angle
Mm-hmm.
the whole time, and this just goes up?
Yes.
Okay.
It's always a right angle. I think your geometry formula in that question needs to be a SOHCAHTOA equation.
That's what I'm thinking.
Yeah. Okay, so I will switch it to the puzzle for today. I think y'all looked at the matchstick one last time. Again, you're welcome to keep working on related rates. I'm sure related rates are more interesting anyway. But you did this last time? Yes? Okay, today is eight short puzzles. See if you can figure them all out. I'll tell you that nobody... Well, I take that back. Somebody did finally figure out number 7. One person has figured out number 7. I think y'all are the last class to see it, so... what's the first one?
Organic.
Okay, 4, get it. I've heard 2 good answers for number 2. See, y'all said 2 different things. I think it's probably supposed to be Jack in the Box, but Blackjack sounds like it would be fine too. What's number 3? Okay, 4. Back door. Number 5. Good. 6.
Blood is thicker than water.
Yep. Blood is thicker than water. 7, we'll come back to. 8, you're probably too young.
Check canceled.
Yeah, check canceled. You know, like you write a check when you're paying for something. Oh, don't look at that. Any guesses for 7? It's kind of an older saying. Huh? What word is it saying? And what shape is it in?
Line.
B line. There you go. That's a little bit of a stretch.
It's a beeline for the door. I'm like, what? I just need to go I just need a break. Lunch isn't enough. You might. And you get the whole class or something. You want?